certainly a good idea to take a look at it because the idea of substituting in for values can sometimes be a little bit confusing. So we're just going to walk through this step by step, make sure everything's good to go. So let's define what an algebraic expression is first. An algebraic expression. Yesterday we just mentioned expressions, right? So like one side of an equation would be an expression. An algebraic expression is a little more specific because it's a mathematical phrase. So a mathematical phrase it's not just made up of numbers, but it is made up of, it does have numbers in it, made up of numbers and variables. All right. So it's a mathematical phrase made up of both numbers and variables. Yesterday, we had mathematical phrases made up of just numbers. So those were just expressions. Today, we're dealing with algebraic expressions. So we are introducing some variables in with those numbers. We're not going to be solving equations. Let me just be clear with that right now. We are not yet solving equations. We'll do that next week. Just because you have variables doesn't mean there's an equation. These are still expressions, basically just one side of an equation. And does anybody remember what a variable is? I know we haven't really talked about that much this year. So what is a variable? Who can tell me what a variable is? Anybody remember a variable? What do variables usually look like? How do we write variables most of the time? Yeah, we use letters. So variables are letters, and what do they mean? What do those letters mean? Ryder? Yeah, they represent any number that you can plug in for that particular expression or equation. In some cases, there's only one proper number, only one number that you could plug in for a variable that actually works. Some cases it's multiple ones. But the idea of a variable, it's a letter that's standing in for a number until we know what that number is. That's all we mean by it. So if you've ever been confused about the fact that there's letters in math, that's all it means. Those letters are placeholders for the actual numbers until we find out what the numbers are, and then we can put those numbers in for them once we have them. Sometimes you are told what the number is, like in today's lesson and assignment. Sometimes you have to find out what the number is, like when you solve equations. So the substitution property is what we're going to be using today because we're going to be plugging in values for the variables. So for example, this says if A equals B, so if two numbers are equal to each other, then A may be replaced for B in any expression. All we're saying is that if the two things, I'll make sure you can see that, if the two things are equal to each other, you can swap them out for one another because they're the same. That's all we're saying. It's like video game controllers, right? Whatever console or whatever, computer you use, whatever for that. If you have a controller and you have your original controller, probably it's just kind of a basic looking controller. And if you want a nicer controller, you can replace the old one with the new one, and it might be, brighter colors or could be themed after one of your favorite video games or whatever, but you can substitute it out because it still works with the machine that you're playing your games on. And so that's what we're doing here. We're just swapping something out that works with the expression that we have. And so this is a 3-step process. I'm going to number these as well. I'm going to say step 1, step 2, step 3. Step 1 is to substitute. Substitute the variables with their given values. So basically, if it tells you what the variables are equal to, in terms of a number, plug those numbers in, replace the letters with the numbers. That's step one. Then once you do that, make sure, and this is kind of an important thing to do, especially when it comes to negatives and especially when it comes to exponents. Each time you substitute a variable with a number, put parentheses around it. Put parentheses around that number because that'll help with identifying whether something is positive or negative, if it's being multiplied, if you're squaring a number, you know, taking it to a certain power. That will be a really helpful thing to do. And then finally, number 3 is exactly what we did yesterday. Follow the order of operations to evaluate. So really, there's no difference in terms of how we do what we're doing today versus how we did things yesterday. The only difference is we're going to start off with nothing but variables, but then it's going to tell us what those variables are equal to, and we'll just swap them in. So for example, if A equals 2 and B equals 4 and C equals 7, plug those values into this expression and then solve. That's exactly what we're doing. So before we do that, I just want to make sure that everybody is understanding what this right here means. This first thing, a b to the second power. When you have two variables right next to each other, what does that mean operation wise? Multiplication, exactly. So this is a times b to the second power. I also want to make it really clear that the only thing here that has an exponent of 2 is the value of b. A does not have an exponent of 2. If it did, it would look like number 3. See down here on number 3? Where A has the exponent and B does not. So this is not A to the second, B to the second. This is one value of A times B squared plus the value of C. So we are going to substitute in 2 for A. So wherever you see A, replace it with the number 2. Put it in parentheses. So 2. Wherever you see B, replace B with the number 4. Squared goes out there. That squared applies to the variable, but it is not part of the variable. So anytime you square a variable, that or take a variable to an exponent, the exponent will be on the outside of those parentheses. And then we're going to add the value of C, which is 7. So we end up with 2 times 4 squared plus 7. So we're going to use order of operations here. The parentheses in this case do not give us groups. These are just isolating these different numbers individually. They're not grouped together in any particular way. So when we work through order of operations, where are we going to begin on problem number 1? What's that? The exponent. Yeah, because there's no groupings, we have to go to the next step of order of operations, which is exponents. 4 squared is 16. That's 4 times 4. So we get 2 times 16 plus 7. Notice I can drop the parentheses. Really, you're just putting them in there initially just to get them kind of isolated and separated from one another. And then once you start working through it, you're good to go. All right, so we got some multiplication and we have some addition. 16 times 2 is 37, and then 32, and then 32 plus 7 gives us our answer of 39. All right, so that's our first one. The second one, same idea. However, this time we don't just have variables, we have numbers and variables. And 3x squared, again, what this means is 3 times whatever x is squared. The squared, the second power, only applies to the x. It does not apply to the 3. And the only variable we have here is x. So every time we see x, we're going to plug in a -2. So we're going to plug in a -2 here and over here. So we get 3 and then parentheses, -2 in parentheses squared. This is why parentheses can be really, really important when we substitute values in, because if we didn't use parentheses, it would look like 3 minus 2 squared, right? And that wouldn't be right. And so we're going to subtract 4 and then times -2. Again, there's no groups here because we're just isolating those values. So we're going to start with the exponent just like we did last time. Negative 2 squared is negative 2 times negative 2. What does that equal? Positive 4. Yeah, negative 2 times negative 2 is positive 4. Positive 4 times 3 is 12. 4 times 3 is 12. When you multiply these two numbers together, that's a negative 2. This minus 4, if I cover this up, would you say minus 4 or would you say something different? You'd say, that looks like a negative now, right? So if I cover up the first part of this, it doesn't look like a minus 4. If I cover up the first part of it, it looks like a negative 4. And that's because it is. Minus 4 and negative 4, technically, same thing. So you're multiplying these two numbers together, they're both negative. A negative 4 times a negative 2 is a positive 8. And then 12 plus 8 gives us our final answer of 20. Now, the other way that you could have written that, if you wanted to keep the minus there, you could have done that. And you would have written minus, and then 4 times negative 2 is negative 8. So that would be 12 minus negative 8, which is still 20, because you would add the opposite. The subtracting is the same as adding the opposite. So either way, it ends up being positive 20. I just like treating, when I'm multiplying, I like to treat a minus as a negative because it gets rid of the minuses and the negatives and just turns it into a positive value, because a negative times a negative is always a positive. All right, notice the next ones that says you try. So I want you to try those 4. Try those 4 problems. I'm going to give you, let's say 5 minutes to do those 4 problems. And again, if you need a calculator, calculators are fine. Grab a calculator if you need one. And we will check back in 5 minutes. Or actually, you know what? Let's just go with 6, because that'll put us right at 8:30. Once you get to number 5 and number 6, when you plug in for that first y value, the negative next to it does not go in the parentheses along with the number. Only the number goes in the parentheses to replace y. That negative does not go in the parentheses, and that will make a big difference in your answer. So just a heads up on that. Yeah, we're working on the notes right now. If the calculations are what's tripping you up, feel free to use calculator. So take this opportunity to give you your daily reminder. Next Thursday is your deadline for any test correction on that first test that we took. If you need to take the quiz that we did on Monday, please stop by for TAT tomorrow because it's Wednesday today and we're not doing TAT today. But if you need to make corrections, tomorrow during TAT would be an excellent time to do stacks. All right, so we're going to go ahead in just a second here and get started on taking a look at those answers. So does anybody have an answer for number 3 that they would be willing to share? Anybody have an answer for number 3 that they do want to share? Let's start taking a look here. Number 3, anybody? Negative 32. Let's see. I definitely got a negative. And my number also ends in 2, but my first number wasn't a 3. Let's see. I ended up with, I got negative 52 on mine. So your first step when you plug in, make sure that it looks like 3 in parentheses squared and then times in parentheses -4 minus, and then in parentheses again, -4 squared. So the first stuff over here on the left, 3 squared is 9. 9 times -4 is -36. That's where that comes from there. -4 squared is -4 times -4, which is 16, but we still have the minus in between there. So is that what happened? Was this a plus instead? So it'll be -36 minus 16, which would be -36 plus a -16 if you take that route, and then you end up at -52. Are there any questions about number 3 before we take a look at number 4, which the answer is already there? So feel free to take a look at the answer for number 4. What do you notice between 3 and 4 that's exactly the same? What's exactly the same between 3 and 4? Yeah, the original expression is exactly the same. A squared times b minus b squared. Between 3 and 4, it's identical. The only difference is the values that we're plugging in. So the process for number 4 versus 3 is going to be the same. We square the first number. 4 times 4 is 16. Multiply by -7, you get -112. And then -7 times -7 is 49, but there's still a minus in between, so we bring that down. So it's -112 minus 49, so we get -161 for that one. Are there any questions about 3 or 4 before we continue? All right. Does anybody have an answer for number 5? Anybody have an answer for number 5? I might randomly call on someone. Let's see. See if I can make my calculator do this. And, 17. All right, so let's see. Hey, Seuss, do you have an answer for this one? For number 5? What's that? You got so -20? Close, real close. I actually just got 20. So that's super close. So the main thing about this one, the most important part of this one, I think, is to make sure that this negative stays on the outside of the parentheses. Because what we're saying here is that this is the opposite of y squared. And the only thing that you plug into the parentheses is that number. You don't keep the negative with it. So make sure that when you plug in the value of y, which is 2, that the 2 is the only thing in parentheses and that this negative stays out front. So 2 squared is 4. With the negative is -4. Over here, we've got -3 times -4 times 2 because x is -4 and y is 2. -3 times -4 is +12. +12 times 2 is a +24. So that'd be a -4 plus 24. So we're looking at 20 for number 5. And then number 6, you can see there, even though the value of x is a fraction, the final answer ends up being a whole number, and it's -174. And we start off in the same way. We take our value of y, because it's the exact same original expression up here. Plug in the -12 for y, square that, you get 144, but this negative outside of the parentheses still has to come down here. So it's -144. And then we get -3 times -5/6 times -12. What I did first with this multiplication is I multiplied the -5/6 and the -12 because I know that -12 divided by 6 is -2. And then -2 times -5 is +10. And +10 times -3 leaves this a -30. So -144 minus 30 gets us to that -174 for number 6. And again, you are more than welcome to use a calculator on these calculations, if that is the part of it that's the most challenging. All right, flip it over, go to the next page. Let's take a look at the rest of these. We've got 6 more to go through. We'll go ahead and do the rest of these as a class. Nice work on those 4. So here we go. Number 7. What do you notice about these next 6 problems? Like in terms of the size of the rectangles? Quite a bit bigger, aren't they? So if the rectangles are bigger, chances are we might have a few more steps to do. So let's see what's going on. Or if there's, you know, a fraction here, then that means we might need some more room. But let's go ahead and plug in. So we've got a equals 3, b equals 4, a squared plus b squared on the numerator. Now here's something you can do. If you know what some of these answers are going to be before you even plug in, you can do that. You don't always have to plug in like 3 squared plus 4 squared like that. And then at the bottom, that would be 3 minus 4. If you know that 3 squared is 9 and that 4 squared is 16 and that 9 plus 16 is 25, you can start off just by writing 25 as your numerator. That's fine. So if you want to do some of that substitution and solving in your head before you write anything down, I'm okay with that. And the 3 minus 4 is -1, so we get -25. So the answer to this one, even though it gave us a lot more room, actually might have been the quickest one we've done so far. Number 8, it's the same original expression. You'll kind of find that is a theme throughout the notes today. So let's see, plugging in, we got a squared and b squared. So that would be -3 squared plus -5 squared over a is -3 minus b is -5. So that'll be 9, that'll be 25, both positive, add them together, 34. 3 minus -5 is the same as adding the opposite. So, or sorry, -3 minus -5, same as adding the opposite. So that's -3 plus 5, which is +2. And 34 divided by 2 is 17. So some of these can be actually done pretty quickly once you plug them in. All right, any questions about 7 or 8? 9 and 10, once again, they give us the same 2 original expressions for 9 and 10. So we're looking at x squared minus 2 times in parentheses x minus y minus z to the 3rd power. So everywhere we see an x, we plug in a 2. Everywhere there's a y, we give a -2. And then every time you see z, you plug in -3. So let's see, x squared. So 2 squared minus 2, and then in parentheses, x is 2. So I'm just going to write 2 minus y is -2. So I'm going to do -2 in parentheses there, which means I actually have to do 2 sets of parentheses on the end to kind of like put everything in there. You can do double parentheses. If you want to change these outside parentheses to brackets, that's fine too. But I usually just do parentheses. I don't usually do brackets unless the problem starts with brackets. And then minus z to the 3rd power. Z is -3. And that goes to the 3rd power. So plugging these in correctly at the beginning is very, very important to every single problem, because if you can work through order of operations just fine and you do it correctly, but you plugged it in wrong at the beginning, you know, that's not going to give you the right answer. So be really careful about that. Let's see, we'll start inside the parentheses because that's what order of operations tells us to do. 2 minus -2, add the opposite, is the same as 2 plus 2, which is 4. And then if I square the 2 at the beginning, 2 times 2, that's 4. And then that's -2 times 4. And then minus -3 to the 3rd power is -3 times -3, which is 9, times -3 again is -27. So minus a -27. We still have one more multiplication to do before we can just start adding and subtracting our way across here. And that would be the -2 times 4, or 2 times 4, which would be a -8 here. So 4 2 times 4 would be minus 8, and then minus the negative 27. All right, so 4 minus 8 is negative 4. Minus a negative 27 would be adding the opposite. So that'd be negative 4 plus 27, which is the same as 27 minus 4, which is 23. So the answer for number 9 is 23. Are there any questions there? Honestly, I don't know about you, but I think the toughest thing for me is making sure that I have the proper amount of negatives in the right place. Because figuring out where the negatives go and the minuses and making sure that they're all in the right spot, that can make or break a problem. So the more we practice this, the more that we continue to use parentheses. I think parentheses do a really good job of like separating things out. Because this minus here, as we go through these problems, the minuses that start in the problem have to remain in the problem. So this minus here stays here the whole way until we get to here, and we can change it to adding the opposite. This minus here stayed in the problem the whole way. So when we introduce a negative versus keeping an original minus, figuring out which one is which can be a bit of a challenge. All right, moving on, number 10. Same initial expression that we were given on 9. So we're going to plug in x, which is negative 3. We're going to square it. We're going to subtract 2. Plug in x again, which is negative 3 in its own little set of parentheses, minus the value of y, which is 4, minus z to the third power. So z, negative 1 to the third power. Then we can go through the same process that we just did. Start inside the parentheses. Negative 3 minus 4 is negative 7. So I'm going to put this negative 2, and then that's negative 7. So times negative 7. Negative 3 squared, I'll go ahead and do this. Negative 3 times negative 3 is 9. And then on the end here, there's a minus. So we bring the minus. Here's that minus as well. Negative 1 to the third power is negative 1 times negative 1, which is 1, times negative 1 puts us back to negative 1. So minus negative 1. And then we're going to multiply the negative 2 and the negative 7, and that's a positive 14. So that would be 9 plus 14 minus a negative 1. Add the opposite is just plus 1. So 9 plus 14 plus 1. If I add the 9 and the 1 together, that's 10. 10 plus 14 is 24. What's that? You got a different number on your calculator? What did I give you? Negative 13. Oh, that's the third power. Okay. Change that real quick and see if it gives you 23. Yeah, cool. All right. All right, numbers 11 and 12. Last two here. So again, with this negative here, this negative will be on the outside of our set of parentheses. So I'm going to write the negative and then a set of parentheses, and then I'm going to place the value of a inside there, which brings in its own negative value because it's negative 2 squared, minus 2 times the value of b, which is 3, times c, which is negative 3, minus the absolute value of c, which is negative 3. All right. So plug it in for 11. This is what the problem looks like when we get everything plugged in. And then we're going to work through it as we have been using our order of operations. I don't see any groups here. So there's no grouping going on here, but there is an exponent. So we'll start there. Negative 2 times negative 2 is 4. But there's also a negative on the outside of the parentheses. So it's going to be negative 4 here for the first value. And then we can multiply these three numbers together. This is going to be negative 2 times 3, which is negative 6, -6 times -3 is positive 18. So these three here turn into a plus 18. The absolute value of 3 is 3, but there's still a minus there. So that'll be -4 plus 18 minus 3. So then we just do the addition and the subtraction. -4 plus 18 is 14, and 14 minus 3 is 11. So number 11 equals 11. All right, last one, number 12. Same initial problem. I want you to try this one on your own. Give this one a go. I'll give you 2 minutes. 2 minutes to work through that. See what you can come up with. Anybody have an answer? Still see some people writing, so go ahead and keep working on it if you need to. If you have an answer, let me know. What's that? 9? Let's find out. So I hear 9. Anybody else have something different? Does anybody agree with 9? I think I heard a yes. Okay. Anybody else agree or disagree with 9 as an answer? All right, let's have a look. So we're going to do the minus stays where it is. And then we substitute in the value of a, which is -3. So -3 goes in parentheses. That gets squared. Then we subtract 2 times in parentheses the value of b, which is -5, times the value of c in parentheses, which is 2, minus the absolute value of c, which is 2. All right, -3 times -3 is 9, but the negative is still on the outside, so this is -9. -2 times -5 is 10. 10 times 2 is 20, so that's a positive 20. The absolute value of 2 is 2, but the minus is still there, so we get -9 plus 20 minus 2. -9 plus 20 is 11, and 11 minus 2 is 9. All right. So for the summary, I think I'm going to go ahead and direct this summary a little bit. And I'm just going to have you write this down. Remember, to always put just the value of the variable in parentheses. That's your reminder. Always put just the value of the variable in parentheses, like on numbers 11 and 12, where if you have that negative out front, that negative a squared or the opposite of a squared, that negative does not go in the parentheses. Just the value of the variable goes in the parentheses. Okay. That's our little summary. It's just a reminder on some of the more specific things that need to be done here. So your assignment, same length as yesterday's, 12 questions. So go take one of these, pass to the back. Tomorrow, we are going to be doing a review of these last two sections. And on Friday, we will have a quiz on the two sections. So basically this one out over 2 days. So that basically means we are done with notes for this week. So tomorrow and Friday, no new notes. Tomorrow there will be a review. Tomorrow there's going to be a review. I'll have you turn in the review. But there will be no real homework tomorrow. There will be homework on Friday. And we're looking at about a little less than 20 minutes. So get started on your assignment. If you have questions for me, please ask. Again, grab a calculator if you need a calculator. Yeah. That's cool. Looks like they're like stitched together. That's big color. No.